the experiment that should have failed, but didn't. By every rule they trusted, this experiment should not have worked. The setup was flawed. The outcome made no sense. And yet it worked anyway. Not once, but every single time it was repeated. What seemed like an error became a crack in reality itself, forcing physics to confront a truth it was not ready to accept. To understand why this matters today, we have to look at how certainty once ruled science. Experiments were designed to confirm expectations. Results that disagreed were blamed on noise, mistakes, or bad equipment. Reality was assumed to be consistent with intuition, but this experiment refused to cooperate. Particles behaved like waves. Waves behaved like particles. Observation itself altered outcomes. The more carefully scientists tried to control the system, the stranger it became. At first, this was treated as a technical anomaly, a quirk of measurement, but repetition destroyed that hope. The results were precise, predictable, and deeply wrong according to classical logic. The experiment was not broken. Assumptions were. What made this experiment so disturbing was its simplicity. Nothing exotic, no extreme conditions, just a basic test revealing that reality behaved differently when watched, as if the universe was responding to attention itself. This was the beginning of a profound unease, because if observation mattered, then reality was not independent. It was interactive, and that idea threatened the very foundation of objectivity. At first, physicists tried to isolate the problem. Maybe particles had hidden properties. Maybe instruments were interfering. Maybe something unseen was nudging the outcome. Every explanation aimed to protect accompanying belief that reality existed fully formed, whether anyone looked or not. But the data refused to cooperate. When particles were not observed, they produced interference patterns. They behaved like waves, spreading out and overlapping with themselves. When observation was introduced, those patterns vanished. The particles snapped into definite paths. The act of watching changed what happened. This was not a matter of disturbance. Even when observation was indirect, even when no force touched the particle, the effect remained. Information alone was enough. Knowing which path the particle took altered reality. This created a crisis. If measurement changed outcomes, then properties did not exist independently of observation. Position, momentum, even identity became conditional. The universe was not revealing facts. It was responding to questions. As experiments became more refined, the conflict sharpened. Delayed measurements altered past behavior. Choices made in the present seemed to affect what had already occurred. Time itself appeared entangled with observation. These results were not philosophical speculation. They were confirmed repeatedly, with increasing precision. Reality was not waiting passively to be discovered. It was participating. By this point, the experiment had done more than challenge theory. It had exposed a limit. There was no clean separation between observer and observed, and that realization was pushing physics toward an unsettling climax. The conflict reached its breaking point when physicists tried to explain what was really happening. Was a particle a wave or not? Did it choose a path only when observed? Or were all possibilities somehow real at once? Every interpretation came with a cost. If particles lacked definite properties until measured, then reality was incomplete. If all outcomes existed simultaneously, then the universe was far stranger than anyone imagined. And if observation created reality, then objectivity itself was in question. The buildup intensified as experiments removed every possible loophole. No hidden signals, no delayed disturbances, no mechanical explanations. The results remained the same. Reality behaved differently when information was available. This forced a painful conclusion. The universe does not merely contain events. It contains relationships. Outcomes depend on how systems interact, not just on what they are. Observation is not passive. It is participatory. Emotionally, this was deeply unsettling. Science had always promised detachment, a way to study reality without influencing it. Now that promise was broken. The act of knowing had consequences. At the smallest scales, reality refused to stand alone. It required context, measurement, interaction. The world was not a fixed script waiting to be read. It was a story that changed depending on how it was questioned. By this point, the experiment had overturned more than theory. It had overturned certainty itself. And one final realization remained, waiting at the edge of understanding. The climax arrives with a truth that still resists comfort. The experiment did not fail because reality is broken. It succeeded because reality is conditional. Once this was accepted, physics moved forward, but certainty never fully returned. The universe was not a collection of independent objects. It was a web of interactions, where outcomes depended on questions asked and information gained. This realization reshaped technology in subtle but profound ways. It made quantum computing possible. It explained why information is physical. It forced limits on what can be known, even in principle. More importantly, it reshaped perspective. Observation is participation. To measure is to influence. There is no view from nowhere. The universe does not reveal itself neutrally. It responds. Today, this insight sits quietly beneath modern physics. It works flawlessly, even if it remains philosophically unsettling. Reality behaves consistently, but not independently. The experiment that should have failed did not expose a flaw. It exposed a feature. The universe is not indifferent to observation. It is entangled with it. Subscribe to join the journey.